Hey guys, this week's lesson is going to be about solving linear systems. This next little unit that we're doing is actually going to be over the next 4 weeks. We're going to have 1 week over solving linear systems, which it should be review for you guys. Next week we're going to introduce matrices. And then the week after that, we're going to multiply matrices, which is a whole other thing. And then we're going to do something, spend a week on something called reduced row echelon form, which is a way of solving systems of equations that is a little bit different than what you've seen before. And then we'll have our mastery quiz. And then we'll have 2 more weeks, and then we'll be done for the year. So, like I said, today's lesson is just on solving linear systems. It's something you've seen before. You did this in Algebra 1. I believe you did this back in 8th grade as well. So let's get started here. I've got 3 examples I'm going to run through, and then if you need more help, you're welcome to join me in Zoom meetings, or you can YouTube other problems. So first off, we're going to solve the system graphically, meaning we're going to graph the 2 lines, see where they intersect, and then wherever they intersect, that's going to be the solution to our system. If you remember how to graph lines, on the first line, we've got 4x plus y equals 8. I can solve this, or I can graph this line several different ways. What I'm going to do here is I'm going to go ahead and just solve it for y, and that gives me y equals negative 4x plus 8, and that tells me then that my y-intercept is at 8, and my slope is negative 4, which means I go count down 4 and then to the right 1, down 4 and right 1, down 4, right 1, continue that pattern, and then I can draw in my line, like so. The other one, I'm going to go ahead and graph by using the intercepts. If you remember how to do that, if you plug 0 in for x, that gives you the y-intercept. If you plug 0 in for y, that gives you the x-intercept. And so if I put 0 in for x, that tells me I've got negative 3, y equals 18, and so y would have to be negative 6. Which is right here. And then if I plug 0 in for y, that gives me 2x is equal to 18, and so that tells me that x is equal to 9. Which is right here. And then if I connect those, like so, it looks like this point right here, where they intersect, would be a solution to the system, which is the coordinate 3, negative 4. And then to test my theory that 3 and negative 4 is the solution to this system, I plug it into both equations. And so if I plug 3, negative 4 into the first equation, that's 4 times 3 plus negative 4 equals 8. So that's 12 minus 4 equals 8, so it works in the first equation. And then I plug it into the second equation. 2 times 3 minus 3 times negative 4 is equal to 18, so that's 6. Negative 3 times negative 4 is positive 12, equals 18, and so it works. And so it works in both equations. So my solution to this system is, in fact, 3, negative 4. That's solving a system graphically. And if you can do that, it works out just fine. Sometimes you can't solve it graphically, or sometimes you don't want to solve it graphically, because it is a little bit more work solving it that way. We have algebraic methods to solve it. And remember, we have 2 algebraic methods that you've dealt with in the past. The first one we're going to look at is substitution. Now, in substitution, remember we solve for one of the variables, plug it into the other equation, and then solve it. And then once we get that done, then we solve for the other variable. So in this equation, 2x plus 5y equals negative 5, x plus 3y equals 3. A real quick indicator is that I've got one variable right here, x, that is all by itself. It doesn't have a coefficient on it. There's no number in front of x. And so that tells me that I can easily solve for that variable by moving 3y to the other side So I get x is equal to negative 3y plus 3. And which means I can take negative 3y plus 3 and plug it into x in the other equation. And so my new equation comes out to be 2, but instead of x, it's going to be negative 3y plus 3, and then plus 5y equals negative 5. And then I finish solving this. Distribute the 2. Combine like terms gives me negative y plus 6 is equal to negative 5. Subtract 6 on both sides. I get negative y is equal to negative 11. So y equals positive 11. And so then I take 11 and plug that into y up here to get x. So it'll be x is equal to negative 3 times 11 plus 3. And so x equals negative 33 plus 3, which tells me x equals negative 30. And I'll tell you what, there's no way I'd want to try to graph that, because it looks like my solution now is going to be the coordinate negative 30, 11. And notice I wrote this as an ordered pair because solutions to these are ordered pairs because they are coordinates. And the last step on here is I'm going to check my answer, make sure it works. And so I'm going to take this solution, I'm going to plug it into this first equation and make sure it works. I know it works in the second equation already because that's the equation I used to solve for x. But I need to check the first equation. So that's 2 times negative 30 plus 5 times 11 equals negative 5. So that's negative 60 plus 55 equals negative 5, which does in fact work. So my solution is negative 30, 11. That's substitution. The other method that we have, and that you've learned in the past, is elimination. And elimination is based on the concept that if I have one statement equal to a second statement, and then a third statement equal to a fourth statement, if I add those together, it creates a brand new statement that is also true. It's based on that concept right there. And so we can use that to eliminate a variable. Now, first off, when I look at this equation, I say, well, you know what, if I add everything straight down, like so, I'll go ahead and do it right here. This is going to give me 9x minus 15y equals 18. That doesn't help me at all, does it? Because I didn't eliminate a variable. It doesn't help. So what I can do, though, is that if I take this equation here and I take this top equation, say times negative 2, and I distribute that negative 2 to everything in the equation, that gives me a brand new equation, negative 6x plus 14y is equal to negative 20, and then carry the second equation down or over, and then I add down. Watch what happens. Negative 6x, positive 6x, that's 0. That goes away. And all I have left here is 14y minus 8y is 6y. And negative 20 plus 8 is negative 12. And then finish solving this by dividing by 6. I get y equals negative 2. And just like that, in 2 quick steps, I all of a sudden have my solution for y. And I can find x by plugging negative 2 in for y in one of these two equations. It doesn't matter which one. So I'm going to say 3x minus 7 times negative 2 equals 10. So 3x, that's plus 14 equals 10. And subtract 14. And divide by 3, I get x equals negative 4 thirds. And that'd be a real nightmare to try to graph, wouldn't it? And it would also be a real pain to use, I guess you could use substitution on this, but you're going to have a real nasty answer or real nasty value for x or y, however you decide to use substitution. So elimination is really your best bet on this. And now we can check our answer. We're saying that negative 4 thirds, negative 2 is our answer here. And so let's plug negative 4 thirds, negative 2 into the other equation. So 6 times negative 4 thirds minus 8 times negative 2 is equal to 8. Well, 6 times negative 4 thirds, that's 6 times 4 is 24, divided by 3 is 8, so that's negative 8. And this is plus 16. Negative 8 times negative 2 is 16, equals 8. And negative 8 plus 16 is, in fact, 8, so it does check. So my solution here is the coordinate negative 4 thirds, negative 2. Okay, so guys, I went through really quick with just 3 examples here, one in using each method. If you have questions, you're welcome to join me in any of the Zoom meetings this week, or you're also welcome to YouTube other videos on how to use elimination or substitution. And I hope you're still engaging in continuous learning, and I will talk to you guys later.